Okay, hello Cloud Gurus and welcome to this lecture. In this lecture, we're going to look at network access control lists versus security groups. So this is what our environment looks like right now. We've got our NAT gateway. It's sitting in 10.0.1.0. It's got a route out to the internet, and we've got our instances sitting in our private subnet, and it has a route pointing to the NAT gateway, which then has a route out to the internet. Let's go over to the AWS console. So I'm over in the AWS console. Let's go over to services, and we're going to go over to our VPC, and we're going to have a look at our network access control lists in our VPC. Network access control lists are under security, and we'll be able to see our two network access control lists, and they're both our default NACLs, and one sits inside our custom VPC, one sits inside our default VPC, and they're associated by with two subnets and three subnets respectively. So to view our default NACL, just click on it and you'll be able to see inbound rules. And you'll see here we've got rule numbers. Now rule number 100 is for IPv4, because you can see the source in here. And rule 101 is for IPv6, and Amazon always recommend that you use increments of 100. So if you were to add another rule, you would add for IPv4 a rule number 200, or for rule IPv6 you'd add rule number 201. If you do want to make it so you can see it a bit better, just click on this icon in here. Our outbound rules has similar things, so rule 100, rule 101, these are our allow rules, these are our deny rules. So in order to go ahead and start using network ACLs, let's create a new network ACL. I'm going to call this My Web NACL, and we're going to select the VPC that it's going to go in. So I'm going to use the A Cloud Guru custom VPC, and I'm going to go ahead and create it. Now, what do you think our new network ACL will look like in terms of its rules? If we click in here, you can see automatically the inbound and outbound rules is to deny everything. So we're going to deny everything by default. So remember that whenever you create a new network ACL, you're going to deny everything. Okay, so let's go ahead and test this, and we're going to test this by setting up a web page on our web server. So if we just go over to EC2, grab the public IP address of your web server. We just need to log into it and go ahead and install Apache and create a little web page. So I'm actually still SSH'd into my private database server, and you can actually just type in exit and then exit, and that will take you back to your web server. So you can see I'm now on a different IP address. I'm on 10.0.1.89. So I am on my public web server now. And I'll just type in service, HTTPD, and then status to see if it's in running. And it hasn't even been installed. So what I need to do is just type yum install, and then HTTPD, and then -yes. And that will go ahead and install HTTPD. Then we want to go, and I'll just clear the screen so it's easier to see. So we want check config, and then HTTPD, and then on. And then we want to run service, HTTPD, and then start. That'll start our service. Then if we just go over to our cd var www html directory, and in here we can see that we don't have anything. So all I'm going to do is I'll just do this in nano actually. So nano index.html. We're going to go ahead and create a little web page. So I'm just going to type HTML, and then header, and then hello cloud gurus, and then I'm going to end my header, and then I'm going to end my HTML. And there we go. So now all I'm going to do is exit. Yes, I'm going to save it and hit enter. And if we do ls, we can see our index.html. And if we cat our index.html, you'll be able to see the code inside it. So I'm back over in my calendar. If I just type it in here, I should be able to see our web page. So there we go. Hello, Cloud Gurus. Okay, so I'm back in the AWS console, and the reason that is working, let's just go over to our VPC section and go over to our network ACLs. So that subnet is currently associated with our default subnet, and our default subnet has the inbound rule to allow everything. So it's going to allow all traffic in here. That's why HTTP can go through this subnet. What we're going to do is we're going to move our subnet over to this network ACL, and then we're going to start experimenting. So if we just go into this network ACL, and what we can do is click on subnet associations. We can edit our subnet associations, and we're going to associate this subnet, so 10.0.1.0, to this network ACL. So I'm going to go ahead and hit edit. And now we can see that that is now associated with this subnet. If we click in here, we can go back over to our default subnet and have a look. And you can see now that it's no longer associated with our default subnet. It has now moved over to our web network ACL. And if I go back to my web page and I refresh, it's just, you can see down here it says connecting. It's just going to time out because currently we haven't set up this network ACL to allow HTTP traffic to come through. And you can see now it says this site can't be reached. So we are now no longer able to access that website. So how can we fix this? Well, we need to add some rules to allow us to be able to see HTTP. So we're going to click on Edit Inbound Rules, and we're going to start adding our rules. I'm going to start with rule 100, and they go up in increments of 100. And we're going to allow port 80 in from the source all addresses. And then I'm going to do the same with rule 200, except this time I'm going to allow HTTPS, so port 443. And then finally, I'm also going to allow SSH in. So I'm going to allow port 22, and we're going to allow that in from the world. So let's go ahead and hit save. And now what these rules are doing is it's allowing us to connect in on port 80, port 443, and port 22. But it's only allowing inbound, it's not allowing outbound. So we need to go and add some outbound rules as well. And we're going to start with rule 100, and we're going to allow port 80 in here. And then we're going to add a rule, so we're going to allow rule 200. And then in here, we're going to allow port 443. And then in here, we're going to add our rule. So we're going to add a third rule. And this is where we add what's called our ephemeral ports. And I'm going to explain what they are in a second, but we're just going to type in here 1024 and then to 65535. So those are our ephemeral ports. I'm going to go ahead and hit save. So let's talk about what ephemeral ports are. So Wikipedia has a pretty good explanation here. It talks about ephemeral ports as short-lived transport protocol port for IP communications, and ephemeral ports are allocated automatically from a predefined range by the IP stack software. It then goes on to talk about servers. So it says on servers, ephemeral ports may be used as the port assignment on the server end of a communication. So this is what's happening on our web server. This is done to continue communications with a client that initially connected to one of the server's well-known service listening ports, so like port 80 or port 22, etc., etc. It says here that the allocations are temporary and only valid for the duration of the communication session. After completion or timeout of the communication session, the ports become available for reuse. Down here it talks about the different ranges to use for ephemeral ports. You might be wondering why we use the specific range that we use. And if you go over to the VPC documentation, I'll include a link to this in the resources section of the course. You can read about ephemeral ports in here. The reason we use the ports that we did is because a NAT gateway uses ports 1024 to 65535. So that's why we chose that port range. So now I'm back on my little website. If I hit refresh, we get our web page. So we have now associated our subnet to that network ACL, and we've gone in and added our inbound rules and our outbound rules, and we are now able to connect to that over port 80, and we can see here we are able to view our web page content. So I'm back in the VPC dashboard. In here we can see our inbound rules, and we can see what's happening. So the rules are being evaluated in order. So rule 100 is being evaluated before rule 200 and before rule 300, and that's the way it works. And then it denies everything else. So we're allowing in port 80, we're allowing in port 443, we're allowing in port 22, etc., etc. So what we could do is we could go in and edit our inbound rules, and we can go in and add a deny rule. So let's go in and add a deny rule for port 400, and I'm going to deny port 80, and I'm going to deny it to my specific IP address. So you can type what's my IP into Google, and it will give you your IP address straight away. So go ahead and copy that into your clipboard. I'm going to paste that in here, and then I'm just going to do /32, and I'm going to go ahead and change the allow to a deny, and we'll see what happens. So that is now denying my specific IP address through this security group. And so now I'm on my web page, and if I hit refresh, I can still see the page. So why is that? Well, rule 100 here is trumping rule 400. So rule 100 is allowing everything in on port 80. It's not denying my specific IP address, because my specific IP address is at rule 400. So you have to bear that in mind when you So you have to bear that in mind with network ACLs. They're done in chronological order. So if you've got a deny, you have to have the deny before the allow. So I'm back here. Let's go ahead and edit our inbound rules. And we'll change this rule from rule number 400 to rule number 99. We'll go ahead and hit save. So now we've got rule number 99, which is denying my specific IP address, and then it's allowing all other IP addresses. And so if I go ahead and hit refresh in here, you can now see it says connecting, and it's going to time out because it is denying this specific IP address, but it's allowing all other IP addresses in. So this comes up an awful lot in the Certified Security Specialty exam. You need to understand how network ACLs work and how the rules work. And you can have a specific deny, but if you've got an allow before the deny, then that rule is not going to work. So you have to have a good understanding of that going into your exam. So before we go on to my exam tips, I just want to remind you of a few things we've learnt in this lesson. So when we created our VPC, a network ACL was created by default, and it's called our default network ACL. And every time we add a subnet to our VPC, it's going to be associated with our default network ACL. You can then associate the subnet with a new network ACL, but a subnet itself can only be associated with one network ACL at any given time. That being said, network ACLs can have multiple subnets on them. So I could go in here and I could go and add a new subnet association. So I could go and add this one. So we can have many different subnets associated with our network ACLs if we wanted. And then, of course, as soon as we do that association and as soon as we make any rule changes, those rules take effect immediately. And just remember that rules are done in chronological order. And if you have a deny first, that's always going to deny, even if you allow it later. If you're going to deny a specific IP address, you want that rule to be evaluated first. Now, this will come up an awful lot in the Certified Security Specialty exam. It doesn't come up in the Certified Solutions Architect Associate exam too much, but it is a good thing to know in real life. I remember that when you're using network ACLs, they're always going to be evaluated before security groups. So if you deny a specific port on your network ACL, it's never even going to reach your security group. So network ACLs always act first before security groups. And so on to my exam tips, and we're basically just going to summarize everything I just said. So your VPC automatically comes with a default network ACL, and by default, it allows all outbound and inbound traffic. And then you can create custom network ACLs, but by default, each custom network ACL denies all inbound and outbound traffic until you go ahead and add rules. And each subnet in your VPC must be associated with a network ACL. And if you don't explicitly associate a subnet with a network ACL, then the subnet is automatically associated with the default network ACL. And you can block IP addresses using network ACLs. You can't do this using security groups. So if you're always given the choice, you use a network ACL to block specific IP addresses. And just remember that you can associate a network ACL with multiple subnets. You can have as many subnets in there as you want. However, a subnet itself can only be associated with one network ACL at a time. And when you associate a network ACL with a subnet, the previous association is removed. And then network ACLs contain a numbered list of rules that is evaluated in chronological order, starting with the lowest number rule first. And network ACLs always have separate inbound and outbound rules, and each rule can either allow or deny traffic. And network ACLs are stateless, so responses to allowed inbound traffic are subject to the rules for outbound traffic and vice versa. So you need to go in and add rules both inbound and outbound. With security groups that are stateful, you don't need to do that, but just by allowing it inbound, it automatically allows outbound as well. So that is it for this lecture, everyone. Hopefully you understand network ACLs in a lot more detail now. In the next lecture, we're going to cover off custom VPCs and elastic load balancers. So if you've got the time, please join me in the next lecture. Thank you.